Hello, I'm Larry from Fixed Team. The previous lesson explained that the CPU needs to be disassembled under different current conditions. This lesson will not repeat this content. Go directly to the topic. Learn which line need to be measured for iPhone 6s A9 CPU. Let's switch the screen and observe on the schematic. This is the A9 CPU. First, observe the first line. First line RAM 1.1 voltage, that is the capacitor C2043. Second line RAM 1.8 voltage, that is from the capacitor C2030. Third line system VDD voltage, that is the capacitor C2051. Next, measure this row of lines. Click this. Touch this position to measure with a multimeter. There are also capacitors. This is the VDD voltage of the SoC. Click the one on the left. This is the system GPU power supply voltage. Here is connecting. Just measure this side is okay. Last line system supply voltage. Measure the right side or measure this capacitor, that is the capacitor 2001. iPhone 6s is just these lines. This is the first line, second line, third line, fourth and fifth lines, and sixth line. The above is where the iPhone 6s CPU needs to be measured. The line measurement here is just right. It is difficult to measure the place because of the glue. So just check the right side. The inductors are connected. You can also measure whether there is a problem with the voltage. Need to measure when removing or installing CPU. If there is short circuit in those lines, the power supply IC, which in the back side is bursting, even 10 points connected. Then we have to read out the power supply IC. Next, look at this phone. This is the mobile phone that needs to disassemble and install the A9 CPU today. This is a mobile phone with wallpaper and password. You can see the wallpaper after disassembly. Start. We now start to remove the shielding cover. Remove the shield cover, temperature 380, wind speed 30. Hot air gun rotating blow. In order to show the operation here, in reality, there is no need to disassemble under the microscope. After thin melts, pick it up. Has begun to melt. Remove the shield cover. Clean thermal paste. The difference between A9 and A8 is that the RAM is very fragile and easily blown to broken. So the first step is not to remove the edge glue, because the RAM is easy to burst. First, deflate it. This is a very important step for A9. Disassemble the upper and lower layer to expel the air inside. And then, it can be the same as the A8 step, will not be blown out. Take out the blade. Use this blade, which is to pry the CPU. Ready to deflate. I pick it up and show it to everyone. Between the top and bottom of the A9, here between green and black, the point, which is in 2 layers of yellow, is to operate here. Actually parallel to the capacitor. Deflate now. Small air gun nozzle for deflation. Hot air gun temperature 390, wind speed 40, same as A8 CPU. Be careful, small air gun nozzle. Only hit the deflated point. Do not hit 2 other places. Waiting for melting. Try it out, don't push too hard. Continue to wait melting. You can see that the blade is in. This time the deflation is completed. Change the knife. After this way, the round will not burst. You can remove the edge glue. Because the air is already out, change the blade. Change to curved blade to clean glue. After the deflation is completed, the round will not be blown out. If you pry directly, the round will definitely be blown out. The round broken and you need to change it. It will be very troublesome. So you need to do the deflation. Clean the glue. Temperature 320. wind speed 30. Basically consistent with A8. Start removing glue. Cut the glue next to it. iPhone 6s glue will be a little more than iPhone 6. Don't worry. This temperature is very safe. These are the original tin. The temperature does not melt the original tin. The glue here must need to be removed. The problem have not cleaned the glue around inductor and pressed CPU to let it loose is the reason why the CPU is not installed well. They don't work well, so does the CPU. Be careful with many resistors and capacitors. More on the other side, here is better. Be very careful on the other side, they are all useful. Be careful here. Here are basically resistors, more than 90% are useful. Be careful, gently don't take the resistor away. After the glue is removed, you can start prying the CPU. The CPU has been deflated, and today show the method of remove one layer by one layer. Now start disassembling A9. Without nozzle to heat, not easy to drop points. Same as A8, temperature 390, wind speed 40. Use this kind of blade. Confirm temperature and wind speed. Without nozzle and gun rotation. Find the point you just handled to let the air come out. Feel the tin melt. Insert it immediately. The RAM is down. Then bring the lower layer together. First try. The lower level is also inserted. Gently. Without nozzle air gun to blow all tin will melt, will not drop points. It didn't melt. It will not happen if you were torn down. Observe the remove A9. The pads are very beautiful. These yellow copper skin are the NC pins of the pad. Don't worry. a dropping point here. You need to check the schematic to see if it is a useful point. The ramp is also very beautiful. First, deal with the path. Add 183 tin while the path is still hot. Add some flux. Use a small quarter head of the soldering iron. Mixing. Let each solder joint get the 183 tin. Try to use soldering iron to remove the glue and tin in iPhone 6s. There is a PMU behind and it is very easy to burst tin and tin point connect. If you find that the tin is cracked or tin point connect, you will have to reball the PMU. Use soldering iron after replacing the tin. Use the small quarter head of the soldering iron to clean the glue. Be careful of the resistor at the edge. Shovel it off with a blade. After shoveling, use solder wick. Remove the tin. It is very convenient to use a small quarter head for CPU to remove tin and glue. Better to use than other blades. Be careful not to touch the resistor. They are very dangerous. After processing, use the 11 blade. Install the nozzle. Temperature 320, wind speed 30. Cut the edge glue clean. Try not to use hot air gun long time on 6S CPU. Move fast. Shorting power supply IC is more common after handle CPU in iPhone 6s. Pay attention to remove the black glue next to it. Especially the corner position. The same method is used here. There is less glue here. The blade after polish is not easy to hurt the layer. But the knife is too sharp and easily cut the board. The glue has been removed here. You can use the back of the knife here. Treat the glue in the middle path. It should be noted here that the periphery of the CPU uses a knife tip and the middle uses a knife back. After finishing the glue, apply thin again for the solder joint to be smoother. Let all the pins get the 183 thin. Repeat the action just for each solder joint. Use a solder joint to cut away the discard part. Just fold it lightly to start cleaning. Places that are not up too thin will be cleaner again. Cut out the used white part in time, and the red part is clean. When cleaning, please pay attention to the small resistance of the soldering iron. If you don't find a small resistor missing, a certain function of the CPU will not be used. Continue to use clean area. This is done. Clean it. Use cotton. Cleaning debris. Heat it with an air gun to make the PCB wire evaporate a little faster. Check the edge side glue. Observe the solder joint. Check the pad. After checking no problem, this pad is treated. See if there is any drop. Continue checking solder joint. The pad is processed. Then we need to measure the resistance of the board. See if the power supply IC have short. The first one has resistance. Red pen grounded, black measurement. SIM card holder, shielding cover, posts are all grounded. The black pen measured these points. The second has resistance. The third has resistance. The fourth has resistance. They measure the edge here. There is resistance. This one has resistance. This one has resistance. This power supply IC is definitely no problem. No short circuit found. Then we also need to use DC power supply to measure. Test the current of board without CPU. Check the power supply to see if there is a short circuit. Use this DC power supply. Look at the current of the board without CPU. Clip on. Observe the current. In this case, 0.00 to 0.03 is normal. The bottom of the board on the A8 CPU of the iPhone is generally 0.02 to 0.03 this current. 0.03, 0.02, 0.01 are normal. Above success is generally 0.00 and some will be 0.01. They are normal and need not to be considered too much. Generally, the iPhone 6s show DC power supply full short, and the PMU must have short. It is problematic that the back capacitor is 10 point connected, and the boot current is about 30. Next, we look at the CPU. This CPU seems to have dropped a point just now. Let's check. There are 2 drop points here. Check if these 2 drop points are useful. This hidden line connected is mostly useful. Now that the CPU point drops, deal with the path first. Apply some 183 tin. Then apply some flux. Let all the point get the 183 tin. There is very little glue on the 6S CPU. Basically, take it off with a soldering iron. After taking off, just use a solder wick to straighten it. The glue on the 6S is very easy to take off. This completes the handle of the pad. Cleaning. After cleaning, we found another drop point. There should be a fault in this position. Let's take a look at what these 3 points function. First, find the point of A9 on the glass. Here is the A1 pin. Let's look at where these points are located. Let's count. Count from here. 1, 2, 3, 4, 5, 6, 7, 8. Here. 1, 2, 3, 4, 5, 6, 7. Vertical 8, horizontal 7. Let's look at the schematic again. Vertical 8, 1, 2, 3, 4, 5, 6, 7, 8. Horizontal 7, 1, 2, 3, 4, 5, 6, 7. This is a pin of power supply. Encounter the dropout of power supply in daily life. In this CPU, as long as there is a power supply point in the line is still in the path, this line can work normally. There is no need to jumper this power supply pin. This power supply pin is special. All red dots are power pins. As long as another red dot works, this line will work normally. So it doesn't matter if you lose a power point, because there are many pins on this path on this line. Switch back to the operation screen. Find A1. Here, reverse the CPU. This corner. Measure these 2 points if it is useful. 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 and 10 positions. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. 3rd and 15, 5 and 10, let's take a look. Here, 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This point is the position of the corresponding baseband. This is the baseband line, which is definitely useful. It is necessary to make up here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. This is a ground pin. This is a GND. From this, we can conclude that we only need to fill in 1 point. Just fill in AM26. Other point don't need jumper, and cover it with green oil. From this, we can see that here is the power supply pin. Here is GND. So only need to jumper this one. Use the PCB holder. After the comparison just now, we already know which point to jumper. So how do we find out the pin? Here I will teach you. This is the ground pin. It can be clearly seen that this line is coming here. Then look at this one. This is the power supply pin, which is connected to these points. So this is coming here. It is useless. But this one is different. This one, the line is under the CPU. Scrape it away, but be careful not to damage the pins. Scratch out this pin. The road here is from here. Found it here. Enlarge the screen. Use PCB water. It can be clearly seen that this line is going up. This is the pin here. This is the pin of this. This line is going up. This line is the next line. Washboard. This line is going this way. His line is from a broken line. This head is broken. It must be connected to our own solder joint. Here is connected to here. This is a broken solder joint. This left line point is from upper point, and the right line point is from the missing point. So this is the line we need to jumper. Use green oil to make up the two solder joints next to it. The line left behind is not connected, and the one going this way is we need to jumper. Adjust the microscope. Use the UV light to cure it. Finish curing. The curing with air gun will be faster. Scratch this pin a little. You can add some tin and jumper. Add some tin. You can jumper now. Use this thin line. Cut a little. Put it here. Use air gun. Wind speed is lower a little. After welding, circle these streets. Cleaning. In this way, after reball, this point will be more stable. Apply green oil and scrape out the lid. By the way, make up the green oil of the two solder joints just now. Wait for curing after applying green oil. Use the air gun to heat and cure fast. Scrape out the solder joint of the jumper wire just now. After the solder joint come out, you can also handle the solder joint just now. Clean up. This green oil hasn't cured well. Make up again. This CPU pad is treated. In this state, you can reball it in a moment. Now deal with this layer. This layer is basically the same as A8, but the glue will be less than A8. The glue of the middle layer is to the upper ram. The same principle, we follow this glass. We can see that there is a very little glass. Shower a little thin. It can be seen that there is very little glue. Observe under the microscope. Success is completely different from A8. It can be observed that there is no glue at all. The holes of solder joint are very smooth. Some part of A9 also have glue in this place, so follow the steps of A8. The steps of tin filling are the same as A8. The first step is to remove tin. Add some flux. Then clean the tin. Replace the original tin with this tin wire. The melting point of this tin wire is also 183. Wash off the tin in the middle. Look again after cleaning. All the original factory tin is replaced with this tin wire in my hand. Tin wire with a melting point of 183 is also commonly referred to as medium temperature tin. Continue to clean the middle. Like A8, no foreign objects can be left. Must be cleaned well. Steps A8 and A9 in the middle layer are basically the same. The difference between them is that the RAM of A9 and the PMU are easy to get problem, but the middle layer is easier to handle than A8. The middle layer of A8 is the most difficult to handle. Be sure to clean this glue. When cleaning, you can observe whether there is a foreign object in it. There is no foreign matter now. You can blow 2 bottles of PCB water. Observe carefully the hole of the honeycomb of this 6S CPU. Compared with A8, this hole is very uniform and very flat. Not as uneven as A8, this is very uniform. Check for foreign objects. There is a foreign body here, remove it. Just pick it with a blade. After checking that there are no foreign objects, you can start pouring tin. The pressing steps are the same as AA CPU. Dig out the tin paste and fill it in. Press with a blade so that all the tin will run into the hole. This is the effect after filling. Let's zoom in. It has not been wiped yet. The hole is filled with tin. Don't worry about these extras. We wipe them with a dust-free cloth and observe the effect. Wipe. After wiping now, I see that it is very flat, all in the hole. Smooth the rest of the position. It is what it looks like after wiping. Very flat. This is one of the way we pour tin. This method is suitable for A8 and A9, including all under mid-level tin filling can use this method. Because the maintenance pad dissipates heat quickly, here we put a tissue. Tissue are very good to blow. Temperature 320, wind speed 30, we blow it up. For the first filling, the solder joints are usually not full, usually 2 or 3 times. Observe the effect of pressing. Each solder joint is basically kept flat. There is no need to press tin a second time. If too many times to press tin, it is easy to cause tin dots to connect. Start shoveling tin. Most of them were shoveled. Wash after shoveling, and then observe. Most of them have bright edge, and the bright edge are shoveled. This shows that the tin in this hole is already full and at the same level. No problem, you can start reballing. Use this tissue to fold twice. Same as AA screws. Put it in a suitable position. Then clean the stencil. Bounce off the moisture and foreign matter inside. Observe if there are any foreign objects under the microscope. If not, you can align the position. Prepare a curved tweezer. If there is a bulge, flatten it. Remember to use tissue to absorb moisture. First, align the location of the thin point. Press the stencil well. Use tweezer to press wherever it bulges. Press where to plant. Start here and press it well. After pressing, use blade to shovel off the excess. After planting, wipe off excess tin with a dust-free cloth. Then use straight tweezers to follow the air gun into a triangular layout. First, blow evenly to prevent bulging. Tweezer follow the nozzle in a triangular pattern. The temperature is 320 and the wind speed is 30. Adjust the lens. Don't worry, wait for the cooling to take off the stencil. Now let's take a look. This is where the dropping point will jumper. These are useless points. This is the effect after reballing. Observe the place just jumper the line. Here. You can reset it now. Don't need to care about those useless points. Useless points will get stuck in the stencil during reball. Reset. Clamp it with a tweezer when resetting. It may move if you touch the tissue. The lens in the lower left corner can be clearly seen. Useless points are leaking out. Other points are very uniform. Then we can put this back to the pad. First, clean the pad. Cleaning. The air gun blow after cleaning, evaporating faster. Use some rosin. After using rosin, there are such foreign objects to pick out. Small particles don't matter. Blow it, add some flux. Then you can install the CPU. Take a look at pin A1. This is pin A1. There is a dot in the upper left corner, so here is the A1 pin. Position this pin right. Control the gaps on all four sides. Adjust the gaps on all four sides. Each side needs to leave a gap. Observe this gap and blow without problems. Temperature 380, wind speed 30. Rotate the air gun to blow it back. Waiting for bubbling. We have a reset process. Now bubbling. Continue to wait. Don't push it with tweezers now. There is now a reset state. Don't worry. Move it. Only then use tweezer to gently push. Okay, it has a return process. This is already installed well. Take out the fan to cool it. Put it on and wait. After cooling, use a multimeter to test those points. Why we need to test it? Improper operation will damage the CPU if it is powered directly. So you must use a multimeter to test whether the circuit is normal before you can test the power. Remove the fan. Open the multimeter this page. Red pen is ground and black pen is used for measurement. Adjusting the microscope. The first line has resistance. The second line has resistance. The third line has resistance. The fourth line has resistance. The fifth line has resistance. Okay. Only after all normal conditions can the power on test be performed. As mentioned in the previous lesson, the current without ramp is this current. Let's test if this moving current. Normal when swinging back and forth at 0.06, 0.07, 0.08. The length of the line is not enough here. Here is the power supply. The pointer jumps back and forth. In this way, the lower level is successfully installed. This current also explained in AA CPU. I won't explain too much, just install the RAM. Now start processing the RAM. The glue of A9 RAM is softer than RAM 8A. The first step is to apply some tin. Add some flux. Wait for the soldering iron to heat up. Clean this solder joint. You can also remove glue when you clean this solder joint. This black one is glue. Shower it with a soldering iron. Be sure to use a straight color head instead of bend, because the bend will damage the RAM. Use solder wick. If there is tin on the strip, it will be very easy. The glue in the middle can also be taken off with a solder wick. Use dust-free cloth for cleaning. Let's look at it again. Let's see if the glue we just removed is very clean. Check if there's glue and shower it again. Check it again. Sometimes it doesn't matter if you scratch it a little because the surface is grounded. Deal with the glue again. There's basically no problem now. You can reball. Remember to cut the edge glue before reball. If the edge glue is not cut, it is easy to cause failure for laminating and the lower layer is pushed to the top. Prepare to reball. This tissue has been damaged. Change it. Tissue fold in half. Remember to clean the stencil. It has been washed here. There is a small tin to be removed. Pay attention to details. First, align the position. Tweezers hold a position where tin is to be pressed. After wiping the tin, spread the tweezers and press the free position on both sides. There is a glue. Remove it. Makeup tin. Use straight tweezers to follow the air gun into a triangular layout. Air gun temperature 320, wind speed 30. Blow tin up. Remove the stencil and inspect the solder balls. You can see the tin balls is okay. Then reset it and apply flux. Remove debris. Now you can install it, but check first. Each solder joint is okay and can be installed. Take out the lower motherboard just to install. It is necessary to shovel again before loading. A little washing water can be added to the blade before shoveling. Thin slack will stick to the blade. This is the effect of sticking to the PCB water. After shoveling, add a little wash water. Clean all around. Clean it with a dust-free cloth after shoveling. This is the effect of scraping the middle layer. very flat, but the residue need to be picked out. Once cleaned, the middle level processing is completed. You put the RAM on top and you can see the result. No rosin is needed for the middle layer, just use an air gun and flux. Flux is applied and the air gun blows beside. No need to blow with an air gun, too much flux will float. Find the position of the white point. Here is the A1 pin, ready to blow up in the right position. Right position, almost here. Temperature 380, wind speed 30, direct blowing. Pay attention to observation. Bubbles will pop up first, and then it will return. Rotate the air gun to blow, because the welding spot of the ram is around. The wind will rotate evenly. Now bubbles are coming. Pay attention to observe. Look, the ram sucked itself back. Gently push it. It is okay. You can check whether it is successful after waiting for cooling. Now take out the fan. Put it in this corner and let it cool. The heat dissipation is completed. It is not hot now. First, it is the same as installing the lower layer. Measure those points. Under the microscope. Test whether the resistance of this point is normal. The red pen is ground and the black pen is measured. The first line has resistance. The second line has resistance. The third line has resistance. The fourth line has resistance. The fifth line has resistance. Last one left. The sixth line has resistance. The resistance of the sixth line is normal. Next, check the current. Connect the DC power supply. Trigger to power on. See if there is a boot. There is a startup current. This is the normal starting current. We can install a mobile phone to test. Switch installation screen. This is the motherboard just now. Let's go to boot the test whether we can boot. Apple screen appears. Waiting for boot. How come this screen shows 5 minutes of inactivity? These 5 minutes should have been accidentally pressed just now. Let's wait a moment. The screen display is normal. Okay. Then the A9 course finish. See you in the A10 lesson. Goodbye.